All right, hello, welcome. It's great to be in Brisbane. I did just fly in from reInvent, so if I make any mistakes, please forgive me. I don't even know what time it is, to be honest. So as the introduction, my name is Sbarski, and I want to talk with you about my adventures with serverless. So I actually named my talk Dancing with Serverless because I thought this is going to be just like George Martin's A Dance with Dragons, only fewer dragons and more Lambda functions. Thank you for the couple of people over there. See, when I practiced this joke at home in front of the mirror, I thought it would be so much funnier, but oh well, I guess you find out live whether something works or doesn't. So this is me. I'm an AWS serverless hero, which probably means that I talk about serverless and AWS a little bit too much. I'm an author of a book called Serverless Architectures on AWS. And here are the covers. I was actually very lucky to have had the first edition of my book translated to Japanese and Mandarin Chinese. Now, I don't speak those two languages, so if you get a copy and you do speak Japanese or Mandarin Chinese, please let me know what it says. I hope it's been translated correctly. I mean, I have no way of telling. I also organize the Melbourne Serverless Meetup. So if you are ever in Melbourne, please pop by. We'd love to have you there to speak or just to attend, have pizza, network with the rest of our group. Previously, I worked for a company called Cloud Guru, which was acquired by Pluralsight last year. I was VP of Content and then VP of Education and Research. And I used to organize a little conference called Serverless Conf. And you will never believe what we spoke about there. Yeah, exactly. It was all serverless all of the time for like 2 or 3 days. And it was a very cool conference because we had people from AWS, from Google, from Microsoft coming together to talk about the future of cloud computing. So really cool stuff. By the way, second edition, last plug. OK, maybe it's not second last plug. This is the second edition of my book that has just come out. It's a photo of Jeff Barr, who is the chief evangelist at AWS, holding a copy. So you know it's real. After I saw the photo, I felt I've made it. This is it. I have peaked. I don't actually know if Jeff has read the book or even opened it. But look, Jeff, if you're watching this in recording, I hope you have, and I hope you liked it. When Dave Thomas invited me to give this talk at YOW, I started thinking, what can I talk to you about? And I decided to come up with a few stories from my experience working with Serverless Stack. And I'll talk about my past and some of the lessons that I learned, as well as some of the things that I'm doing now and how I'm solving certain problems. I will say controversial things in this talk, so I'm just giving you a disclaimer now. I will go against conventional wisdom. So look, this is an open, safe space. I want to be open and transparent with you. Please let me know what you think. If you disagree with me, please tell me. Let's talk about it. Let's debate, because I think we can come to the truth, to consensus together. So I want to hear from you as well. So a little bit about my past and what I've done. So as I said, I worked for a company called Cloud Guru. And if anybody's familiar, this company creates and distributes online video courses to help engineers upskill on cloud computing. And it was started in 2015 by Sam and Ryan Kroonenberg brothers. Ryan created content. Sam built the initial serverless platform in about 4 weeks. And the reason why Sam built it so quickly was because he had another job at that time. I was actually working with him. We were consultants together working in Melbourne. And he had 4 weeks of annual leave, which he accumulated. And he went to Tassie with his family. And he was like, OK, I'm going to build this online school. And I need to do it as quickly as possible. And the initial platform was actually quite impressive, because you could watch video lessons, you could do quizzes, you could buy courses. It kind of had all the expected bells and whistles that good e-commerce platforms have. And because it was just the two of them, Ryan and Sam, and I was the first employee, I joined, I think it was February 2016, it needed to have a very small operational overhead. Scaling was interesting. I remember our small company, I think it was maybe 5 of us by that stage. It was reInvent 2016 and Black Friday. And we were sitting in the hotel room and watching how the system scaled itself, I think to like 40 times what we did on any other day. And it just worked by itself automatically. It was kind of like magic. Because before we'd always been kind of like, provisioning VMs and load balancing and auto-scaling. And here, our serverless platform just scaled itself to handle 40 times our normal capacity. And like I said, it was all serverless and serviceful, meaning that we used a number of third-party services to avoid re-implementing common functionality. So for example, we used Auth0 for authentication, Stripe for payments, just the usual kind of services that we all typically tend to use. And here's a simplified diagram of that platform that launched in 2015, early 2016. So we had an SPA website written in old AngularJS. Does anybody remember AngularJS from 2015? Oh, you poor people, I'm so sorry. God, I still have nightmares sometimes. Oh, that wasn't pretty. Users would authenticate via Auth0. Protected actions like purchasing a course were done by Lambdas, which were fronted by an API gateway. The database that we used was Google Firebase. Interestingly enough, Firebase can communicate directly with the front end using WebSockets. So it doesn't need to go back through Lambda to return a response to the client. So changes made to the database would immediately kind of show up in the user interface. Our video files were stored in S3, normal. And you will notice something interesting about this architecture. It is actually a serverless monolith, right? There's one database, Firebase. All functions are writing to that one database. The front end is even coupled to our database. But you know what? It was actually OK. Like for that time, it worked. It scaled relatively well. It got us to market really quickly, and it worked. So kind of let's move forward. We grew, we hired more people, and we realized that our architecture needed to evolve as well. So this is around 2017, 2018. We decided to move to a more microservices architecture. And not because it was fashionable. The big driver really was our team structure. We had hired various teams and kind of gave them focus. We wanted to kind of achieve that highly focused acceleration with teams who would be accountable for each particular area of the system. So we had a team accountable for the student experience, a team accountable for the business experience, a team accountable for exam taking, for e-commerce, and so on. And so they kind of each owned one or two microservices that kind of reflected what they did. And as you can see in the diagram, we moved to a GraphQL-based approach where we had a GraphQL library in Lambda, again, behind an API gateway, and the endpoint could query multiple microservices and using schema stitching, put together a response back for the client. An interesting element, though, is that we were still using Firebase, and we actually began using Algolia for search. And we use DynamoDB streams, which I'll talk a little bit about in a second, to capture events, to capture changes that happened in our various microservices, and update Firebase, which was still kind of powering our user interface at that time. And it was kind of good because we managed to maintain that beautiful kind of user experience without having to do a kind of a big migration up front. We kind of just gradually re-architected our system. It was all an evolution. And you can think of that Firebase database as a materialized view of our DynamoDB databases, right, which powered our user interface. And by the way, I've tried to use Amazon, what was it, Cloud Search instead of Algolia? And, well, it sounds like AWS gave up on that a long time ago, so don't use Cloud Search. See, I'm saying such things. It's probably recorded, and they'll just revoke my hero status now. But I'm doing it for you. And so think about this. We migrated from a monolith to microservices without ever having to think about infrastructure. We didn't need to think about server provisioning or web farms or load balancers. And over time, we re-architected our entire system simply by changing a YAML file and redeploying. And CloudFormation just seamlessly upgraded our system, and it kept running. And what I'd like to do is actually show the state of our system at that time. So this is around July 2018. So we had 289 Lambda functions grouped into 13 microservices. We had 3.7 terabytes of data in S3, so these are our videos. 107 million Lambda invocations. This is July, yep, this is July 2018. 45 million requests going through the API gateway. We had an egress of 3.8 terabytes of data, so these are videos streaming out to our users. And we had 650,000 users at that stage. I think we grew to 2.2 million at the end. And this was our bill. So I no longer work for the company, so I'm sure it's OK to show this. So there you go. Just remember, this is 2018. The good thing about AWS is that it never really raises prices. So today, that bill could actually potentially be even lower. And I should also mention that for the first 2 years of our company, we paid nothing at all for compute or API. It was kind of amazing because we were entirely within the free tier that AWS provides. So we kind of started our company. We bootstrapped ACG, a cloud guru, and ran for 2 years without paying anything for infrastructure. And so we move forward. Obviously, we have more people now. Our team has grown quite a lot. We further evolve our infrastructure. We added service discovery, so now that GraphQL endpoint could actually find out which microservices to query. Things became even less coupled, which was nice. I should mention that that service discovery mechanism was built in-house because this was done before AWS Cloud Map was released. So I cannot talk for the team now. Maybe they would use something like AWS Cloud Map rather than implementing something themselves. But that's what we did. And my experience really kind of working on our platform, writing my book, talking with smart and beautiful people like yourself, has helped me to understand some of the challenges and the benefits of serverless systems. And I just want to summarize them and tell me whether you agree or disagree. So I think going serverless makes you faster because you avoid a lot of the undifferentiated heavy lifting, right? And I have definitely felt this, and I don't really think that I can go back to anything else. The scaling that you get from Lambda and other services is incredible. Initially, it can be cheap or free even, like what happened to us. But you also have to understand what you are buying as well, because it can burn you. If you have infrequent choppy use, great. Lambda API gateway can work beautifully for you. If you have a need for sustained usage, if you're doing ML workloads, okay, maybe that serverless approach isn't exactly the right thing. So you kind of have to have a look at your use case as well. And you can get into trouble if you're not careful. And tell me if you've done this, because I've done this, I think, 3 times now. So I call this serverless cancer. And this happens when, say, you put a file into an S3 bucket, and then you make a Lambda function invoke on that file, right? It's an event, Lambda function invokes, and then it creates another file and puts it into the same S3 bucket, right? And that causes another Lambda function to invoke. And that function creates a file. And you get it into this endless loop. Now, I did something bad, and I'll show you what I did later. Just remind me. You'll know when we get to that slide. But I created 2 files. So for each file, I created 2 files. And there was an explosion of lambdas just running. And anyway, I was very sad when I looked at the bill, and I had to beg for forgiveness. So all I'm saying is, be careful. Lambda is a supercomputer. It's very powerful. So if you are just starting out, yeah, just be a little careful. Operationally, it is very efficient. You don't need to think about patching virtual machines. We spoke about this, or deploying new clusters. It's amazing in that way. But it doesn't mean that it is actually free of operational concerns, because you still need to know what to do when things go wrong, right? You still need to have a robust way to deploy your functions, make changes to the database. If something goes down, if there's an issue in S3, in US East 1, as sometimes happens, your customers are not going to know or care about it, right? So you need to think about resilience, recovery. How do you escalate issues to AWS if there's an issue? How do you escalate issues to other third-party SaaS providers, whoever you're using? Great benefit is that it's not Kubernetes. Large architectural pivots are possible. Again, they are not going to be free or simple or easy. I'm not saying that at all. But at least you don't need to think about all the VMs and provisioning and how to get them up and running and patching the operating system. You just think about the architecture and the code. And frankly, for my brain, that's more than enough to think about. And lastly, and I think this one is really kind of understated, I have found that developers really love the serverless approach. They love using Lambda. They love using AWS services. It's fun. It's engaging. The feedback loop is very short. And if you want to attract people to your company, think about this. It's actually quite a big benefit. Also, another bonus hint that we've discovered, don't go advertising for developers with 10 years of Lambda experience. That is going to be an issue. You will not find those developers. So just look for people who are willing to learn, who are open to new ideas, who are enthusiastic about technology, just like all of you. That's why you're here today. And those will be the best devs, and they will learn it, and they'll run with it, and create magic for you. So those are all the amazing things. Let's talk about complaints, because I have a bunch of complaints as well. So these are the two biggest ones. I don't know if you have those complaints just like I do. Look, developing and debugging can be difficult. A typical process has been, you write a function, for example, you deploy it to AWS, you test it, you run it, you see what happens, then maybe you fix it, put a console.log statement, deploy it again, then maybe you're like, all right, I need to do some unit tests, mock some inputs, run the function locally on the computer, maybe I need to emulate a few services on my computer, use local stack. But because the cloud is involved, there's still that process of write, deploy, wait, test frustration, and I don't know, I just don't love it, but I think I may have a solution for all of us in just a few slides. So let's see. Observability and monitoring is tricky, and this is true for any distributed system. This isn't really kind of like the issue with serverless per se, because once you have hundreds of millions of function invocations, so you have a bunch of containers running, whatever, things will become hard to observe and understand. CloudWatch is not the greatest service for helping you understand what's going on. And I love CloudWatch. If you're watching this, AWS person, I love CloudWatch, but come on, we all know this. And we've all experienced it. Some tasks are hard or impossible to implement with a serverless approach. Can you convert a 2-hour video file in Lambda? Can you download a file from an old SFTP server? Does anyone actually remember what SFTP is, or FTP? OK. Well, I just aged myself. Functions are ephemeral. They run for 15 minutes. API gateway has a 30-second timeout. Other services have other limitations. And of course, people are still worried about lock-in. And I don't actually think that this is a bigger problem as people say it is. Are you really going to be moving your infrastructure from one cloud to another, or God forbid, going back on-prem? I mean, honestly, if this is something you are considering, you have probably just become Dropbox. So congratulations on that. That's kind of success. So I will tell you how I'm addressing and solving some of those challenges today. So I left A Cloud Guru earlier this year. It was acquired by Pluralsight, and I thought it was time to move on. 6 years, great company, but time to do something new. I had a bit of a break, and my hands started to get itchy. I want to build something again. And so the rule I had set for myself is whatever I build had to be serverless. Okay, that makes a lot of other decisions very easy. Given what I'm planning, wow. My watch just said, I'm not sure I understand. That's, well, sorry about that. Given what I'm planning, I may need a lot of computing and processing power. See, this also didn't happen when I rehearsed. I wanted to leverage as many AWS and third-party services as possible. Like I said, I don't want to rebuild things again. If there's a solution, I just want to use it. I want to focus on what makes me and my product or my project unique. And that's that. And I want to kind of solve local dev and debugging to make it as easy as possible, because that honestly has been a pain point for me from the very start. So I decided to build a little project. It's a little system to enhance my financial literacy, which I've realized isn't very high, and also help me to manage my finances. So I built a system to help me track my assets and liabilities, budget, review transactions, give me insights into my spending habits, help me plan for the future, help me visualize my goals, help me with taxation, all kinds of things. And this could be applied to individuals and small businesses alike. I should mention I'm not a designer, so these screenshots don't look as lovely as I would want them to be. And it's just a project at the moment, but I'm looking for volunteers who may be interested in kind of financial literacy or fintech. Join me, we can work on this together from a technical or functional perspective. Who knows, if we can find a good product market fit, maybe this could turn into a product one day. So if you go to that website, you can leave your email address and I'll get in touch with you. But let's talk about the tech. So to help with the implementation, I decided to use the Serverless Stack framework. Has anybody seen this framework before? Because there are a bunch of frameworks. Okay, not a lot of people, a few. So this is an interesting framework because it provides kind of a way to do local dev and debugging. It is built on top of CDK. It has a nice console for administration of resources. Let me show you the console. Nope. Yep, it's there on the side. It has high constructs like function and config, so you write even less code, and even interesting features like auth. So if you're not familiar with CDK, CDK stands for Cloud Development Kit. It's a project from AWS, and it helps you to define your infrastructure in code, right? So you just use a regular programming language like JavaScript or Go or C#. You define your infrastructure. You use regular programming constructs like conditions and loops. You can create unit tests and so on. And so SST builds on top of CDK, which is kind of nice. You can use CDK directly if you like, but those additional constructs just make writing serverless applications a little bit faster and easier. And here's my favorite feature. So it allows you, SST allows you to do live Lambda development. Because what it does is that SST deploys proxy Lambda functions into AWS, like little stubs, that then proxy requests down to your computer from AWS. The actual function runs on your computer, and then the response is proxied back up. This is all done using WebSockets, by the way. The response is proxied back up to AWS, and things continue to run. Kind of interesting. So you don't need to mock any of the AWS services that integrate with Lambda, right? You don't need to use local stack or anything like that. You don't need to even continuously redeploy your functions. You just deploy them once. SST creates those little stub lambdas and establishes a WebSocket connection to your computer, and off you go. So here's like a little diagram which shows the two little fake functions in AWS which proxy requests down to your computer. Kind of cool. There's a DynamoDB table that keeps track of the connections. There's an S3 bucket, which is used as a temporary storage for very large request-response messages. But it's all handled for you automatically. It's seamless, transparent. You don't need to worry about it. And the cool thing is that in practice, and I've been doing this for a while now, it works very well. You save a function locally. You refresh your page. Everything just runs. And the other thing is that once you get this functionality, you can put breakpoints in your code. So if you use Visual Studio Code, you can just put a breakpoint, and you can walk through your code. And this makes debugging work the way we've been used to it for years. And it's like a revelation to me now. My God, like we did this 20 years ago, but there we go. Now we can do it with serverless. And obviously, a function executing on your computer isn't the same as executing in AWS. You have more memory, you have more CPU, I get all that. But if you're working on logic, if you're fixing some business logic, other issues, then that's fine. Like, it doesn't really matter. But the ability to work on your code locally, to save, to put breakpoints, to step through your code, kind of solves 99% of my local dev issues. So check it out. It's an open source framework. You can begin using it today. It's kind of nice. So we spoke about SST for local dev and debugging. That's good. What about observability and kind of just knowing what's happening in the system? You can use services like X-Ray and CloudWatch. They are built in. They are OK. I've mentioned CloudWatch before. I think a lot of us have had the experience. Now, another tool that I use is called Lumigo. So this is actually a paid product. It's not free, but it's nice. It hooks into your environment, pulls data from your AWS account, and actually presents you with useful, actionable insights. And when things fail, like your Lambda function throws an exception, you get a nice email saying, hey, something has happened, and you can click on the link and then go and kind of explore what has happened. And I think to me, the advantage of using something like Lumigo is that you can find things a lot quicker than you normally would using CloudWatch. I'm not affiliated with Lumigo in any way. I'm just kind of showing you what I use because people ask me about it. So at this point, I just want to talk to you briefly about my architecture. So my product is made out of a number of microservices, let's say. I have a core service that holds your portfolio. I have an exchange service, which does currency exchange. I have a history service which backs up your daily history and changes to the portfolio. I have a cleanup service, which deletes all data, and analytics service, which prepares nice reports. Integration service, which integrates with a number of third-party services like Plaid to pull data out of your bank account if you connect your bank account to my project. And insurance service, receipts service, tax service, all kinds of services. So I'm not going to lie to you and say that I've designed this beautiful microservices architecture that follows best practice. For now, while I'm kind of like building this and figuring out the business model, I have made a number of technical concessions up front. So here is an example. I have two services. I have allowed certain Lambda functions in one service to read and write directly to a database that belongs to a different service, like this. Now, normally, this is a big, big no-no in a microservices world, because it's a bad idea to have this kind of coupling, right? Because if I make a change to the database, now I have to go and find all possible functions that interact with this database, and I have to update all those functions across all possible services. I'm breaking basically all of the contracts. Not a good idea. And in a way, what I've done now is I've created a serverless monolith as well. Because I have defined my microservices, but because I've allowed functions to cross boundaries, kind of everything is now mixed together. There you go. It's a monolith rather than cleanly isolated services. So how could I potentially go about fixing this issue? And I think this diagram spoils the answer already, because one way to fix the issue is to make everything go through an interface, right? If a microservice has an interface, in this case fronted by an API gateway, all requests go through that API gateway. This is like, akin to having an interface for a class, right? You don't care about the implementation of the class. The inner workings may change, but as long as you adhere to the interface, everything is good. Solid approach, works nicely in most cases. Although, to be honest, in some situations it may not be amazing because of the extra latency introduced by the API gateway. And then, of course, you can have some additional complications if you have a number of services that need to be called one after another, for example. But to be honest, in a lot of situations that are not overly complex, this is totally fine. OK. Now, if you don't need an immediate response and you are fine handling eventual consistency, so meaning that things can be updated over time and potentially even in a different order, this is event streaming. It's a very popular solution. I'm sure we will see talks at YOW about event streaming. YOW, this is why I love this conference. Every time I attend, there's always a talk on event streaming, and I always go to it. So you can use the capability built into DynamoDB to stream all changes like updates and deletes and have other functions invoke on those events, process those events, maybe update other databases or send messages or do whatever. So DynamoDB streams is nice because it does capture a time-ordered sequence of item-level modifications, which is good. And this provides a nicer, looser level of coupling. And you are using kind of that capability and robust nature of DynamoDB and Lambda to do it. Quick aside, remember this little diagram from a Cloud Guru architecture, like 11 slides back? I've had people ask me, if you move away from Firebase, how can you re-implement that beautiful kind of functionality that Firebase provided, right? Where it would kind of stream changes to the front end using WebSockets. So I'm going to quickly show you how I would create a Firebase clone just using DynamoDB. And if you do this yourself and you make the next $1 billion company, please remember where you heard it first. please, because I'm remembering all your faces. So first, quickly, let's see how we could create a materialized view architecture without WebSockets. We'll cover WebSockets in a minute. Let's just put that aside. So this is just using regular HTTP read and writes. So first, you create a simple API endpoint and a function to process a request coming in. You have the function update the database. Then you have DynamoDB publish all events, as we spoke about before, using DynamoDB streams. Then you have another Lambda connected to the stream, which invokes on all the changes made to the database. It grabs the change and updates your second materialized view database, right? So this is your read-only view. Now you can have a read API, another Lambda function perhaps to grab data from that materialized view. So in other words, you can have a write API, which writes data to one database, and then you have your materialized view just for reading data. And that materialized view perhaps is presented differently to your user interface. Maybe it's enriched with other things, who knows? With me so far? Good. Now, WebSockets. API Gateway supports WebSockets. And whenever a connection is made via a WebSocket, you also receive a connection ID, which you basically then just need to store somewhere in a cache or a database, wherever. You can always look it up and then send a response back to the client. So basically, that's it, right? You have two things here. The client connects with a WebSocket. You receive the connection ID. You store that information in a DynamoDB. Then when you need to send a response back, you look up the connection ID from Dynamo, and you say to API Gateway, hey, send data back to that particular client. Or maybe you want to send data back to all of the clients, connected to your system, right? Then you can kind of just scan. Okay, maybe don't use scan, but you get all the client IDs, and you send them data, or whatever you want to send. So that's that. So now let's try to mush those two things together to create our own Firebase. So what you'll see is very familiar, because that's basically the previous two slides put together. So first, we create a WebSocket API that receives some messages, some data, and invokes a Lambda function. That Lambda function updates the database, which pushes some data onto DynamoDB stream. Great. That invokes another function, which updates our materialized view, our read-only database, which then, this is a little different, which then pushes its own changes to another DynamoDB stream. This invokes another function, which then looks up the required connection ID, or maybe all the connection IDs, and then pushes out what it needs to push out via the WebSocket API. So this is really kind of like Firebase in a nutshell. And it's kind of cool, because you have your read and write databases. It all happens seamlessly. It's event-driven, which is kind of nice, and it works. One quick word of caution. If you are using DynamoDB streams and you have multiple consumers reading data from that stream, just don't attach a bunch of Lambda functions to it. AWS will throttle you. In fact, they state this: no more than 2 processes at most should be reading from the same stream shard at the same time. Having more than 2 readers per shard will result in throttling. So a better approach then, if you do need to have multiple consumers reading from a stream, is to have just a single function that reads the data, then pushes that data onto an SNS topic, and then you can attach as many other functions to that SNS topic as you want, right? And that's kind of like the preferred way of having multiple consumers in this scenario. This is what AWS suggests. Good, it works, awesome. Now, this is my favorite slide. As I was putting together the previous 3 slides about WebSockets, I was reminded about something called mallet architectures. Is anybody familiar with mallet architectures? Excellent. Excellent. When you go back to work tomorrow, you could amaze all your workmates with a story about mallet architectures. This is going to, if there's one takeaway, take this. So in real estate, a mallet architecture refers to a house which is traditional on the front, but is modern on the back. right? And usually it's done to conform to some neighborhood regulation, right? You have to have all your houses look the same, but they can be modern on the back. Now, in software, we can actually think about our architecture in a similar way. You can have a conventional approach that faces externally, but a more modern approach on the inside. And so WebSockets is an example of this, right? WebSockets are stateful on the front, but are serverless or function-based on the rear or on the implementation side. There's also the reverse mallet, right? Because we can stretch this analogy and just torture it until it dies. So reverse mallet is when you have functions that communicate to all the conventional systems, right? And it's done by keeping a connection state in local memory or a database or cloud caching service. Or a double mallet. Oh my God, double mallet is when you have two old systems, right? Maybe you have some kind of like XML, terrible old systems, and they need to talk to one another, but you implement kind of like that message passing using Lambda or with a functional approach. So you marshal data in a serverless way between the two older systems. Double mallet. There you go. But anyway, that WebSockets architecture that I described in the previous few slides, that's an example of a mallet architecture. There's some useless piece of knowledge for you. Anyway, you don't have to remember it. Back to this. Now, we spoke about event streaming, DynamoDB, excellent. If you want to take your architecture to the next level, and I don't know if I'm running out of time, I think I'm still good, you can take a look at Amazon EventBridge. Has anybody seen or used EventBridge? Really cool, excellent, really cool service. I strongly suggest that you do look at it. It's basically a serverless event bus. And it's super scalable. It supports multiple consumers, so there's no issue connecting things up to it. It provides at least once delivery semantics, exponential backoff for like 24 hours, integrates with Lambda. It's actually a really good service. So if you desire even more flexibility and your events aren't just generated by DynamoDB, EventBridge, good solution to look at. Push your events there, and let multiple services subscribe to those events. Now, another way to subscribe microservices, because in AWS, there isn't just one way to do things, right? As Corey Quinn says, if you want to run containers, there are 27 different ways. But anyway, step functions. Now, I love and use step functions a lot. So step functions allow you to coordinate microservices and make changes in a robust, traceable way. So step functions is a service that lets you define workflows. And it's way simpler to use than the old Amazon simple workflow service, which, as the joke goes, was anything but simple. So step functions is great for distributed applications. It has built-in support for failure states, for retries, parallelization. It integrates with a bunch of services, has observability baked in. I use it a lot, actually. And I would seriously recommend examining step functions if you have complex workflows or failure states. It's very helpful. And one interesting insight that I have gained from using step functions is that it works well as a workflow mechanism within a service at a low level and also between services at a high level. So you can orchestrate things between services. So it's kind of flexible enough for both situations. And again, you can define, deploy it with CDK and CloudFormation like any other piece of infrastructure. It's awesome. So we have Lambda, we have step functions for orchestration, we have all these great things. But some problems are still very difficult to solve, right? And I'm stubborn, and I want to do things serverlessly. I don't want to run Kubernetes or virtual machines, God forbid. So how could we do it? Well, we could potentially take a large problem and then solve it by applying principles like MapReduce and parallelization. Because, like I said, we all know Lambda is a supercomputer. And I bet we can make it run really damn fast. I don't know if I can say damn, but sorry, you may just have to, the editor may have to cut that out. So a couple of years, I actually posed a problem for myself. Can I transcode a large video file with a serverless-only approach? Like I'm talking about like a movie, right? I want to transcode it from 1080p to 720p, for example. How would you do it using Lambda? And before I tell you about my solution, I just want to say that what I'm proposing here is an example, right? I know that there are companies that have actually done this specific thing in real life, but if I needed to re-encode the file, I would just use a service like AWS Elemental's Media Convert. What I want to illustrate to you, though, is the kind of thinking you can apply if a ready-made solution doesn't exist and you do have to invent something that nobody else has solved. So, divide and conquer. How could we encode a large video file with a serverless-only approach? So we know that to solve large problems, a way to tackle them is to break them into smaller parts, process these smaller parts independently, hopefully in parallel, which could be done in Lambda, and then combine them again together to get a result. So here are the general steps you could take if you wanted to transcode the video. So you have your original file. You can split it up using Lambda in parallel. Then you can convert those little video chunks that you have created, again, in parallel to a different format. Then you can start merging everything together to get back a new file. And there's a little link there. You can go check it out. It's my blog post, which actually goes into the architecture in a lot of depth and shows you how to do it. You can also pick up my book, but if you don't want to pay for it, just read the blog. So it's all there anyway. And I'll show you just quickly at a high level how I did it with step functions. So the way it works is this. A user uploads the big video file into an S3 bucket. That kicks off a function that analyzes the video file using ffprobe. ffprobe is part of ffmpeg. It's just a little utility that runs and can kind of scan the file and work out where the keyframes are and where you need to cleanly kind of cut the file to create small segments that you can then transcode and merge together. Then that kicks off another Lambda function which strips out the audio and saves that into EFS or an S3 bucket. At the same time, we can start another part of step functions. There's a feature called dynamic parallelism. So it basically allows you to dispatch a whole bunch of Lambda functions at once to split up the original file into tiny chunks, right? And those tiny chunks are saved to a different format and, converted to a different format and saved into an S3 bucket. And then you can start the merge operation. Now, there is a bit of accounting that you have to keep track of because you kind of need to know which chunks have been converted and which haven't. So there's a bit of an algorithm to this. Again, if you look at the blog post, the algorithm is described. It's actually not that difficult, which is nice. And then at the end, you can start merging things together, and you get the new file. Look, step functions is awesome. It has its quirks. It can be pricey if you use it a lot, but overall, I'm happy with it. There are also express workflows for step functions, which kind of is like a cheaper version of step functions. It has a higher throughput as well, but there are some limitations. I think it only runs for like 5 minutes versus regular step functions, which run for a year. And so when I built the initial system, I think initially I did it just with DynamoDB, SNS, and Lambda, and then I implemented a version of it using step functions. I benchmark kind of a bunch of files. So this is what I got. So I converted the same 6 videos on my MacBook, on an EC2, and using my serverless Lambda. This was just videos I downloaded somewhere. And you can see that in nearly all circumstances but one, serverless Lambda for this use case was actually faster. And I started thinking, is it really, like, did I make a mistake somewhere? But it does make sense, because when you convert a file normally using ffmpeg, say on my computer, it is done sequentially, right? There's just one bit after another bit is converted. But when you do it using Lambda, it's all done in parallel, kind of at the same time. So it's a lot faster. So I'm like, wow, I kind of actually, implemented something good. Another thing that I should mention, at reInvent last week, AWS announced something called Step Functions Distributed Map, which is actually designed to support large-scale parallel workloads. So it's a distributed map state that can launch up to 10,000 parallel workflows to process your data. So it's like designed for this use case. I can see that my time is nearly up. So I just want to quickly go over the complaints. How to dev locally? Yes, but we do have frameworks like SST, which can help us now. Same with debugging. SST, we have some AWS tooling, we have Lumigo. Observability, true, again, Lumigo is good. Hard or impossible to do certain things. Look, maybe it's true. Maybe you do have to use containers for certain things. But I think if you can divide and conquer a lot of the tasks, you can do it serverlessly as well without having to resort to containers or VMs. And again, lock-in problem, again, I don't think lock-in is the problem. I think it's actually where the data is. Can you transport your data somewhere else? I think that's the question you have to really ask yourself, rather than, where is your infrastructure? At least in my experience, that's what I've seen. And as I was finishing up this slide, I was reminded of a talk by Tim Bray from a few years ago at re:Invent. So he defined the rules for modern applications. So he said, think about security and compliance first. Use microservices. Go serverless where possible, right? Serverless first, and then if that doesn't work for you, fall back to other things. Fall back to containers, fall back to VMs, but have kind of that serverless first mindset to help you make better decisions. This is Tim Bray speaking. Make sure you have robust continuous integration, continuous deployment pipelines. Monitoring, and you can check out the stock, that link. It's awesome, it's online, really good. And in about 30 seconds that I have left, I just want to add a few other kind of thoughts to that list as well. First, on the issue of microservices. I don't necessarily think that microservices are appropriate in all situations. And the answer is, it depends. And I know when I was younger, I was very dogmatic, right? I thought, okay, everything has to be microservices only. That's the true way to build systems. I don't think so now. I've seen so many projects. I think it just depends. If you're working on a small project, if you're working within kind of a narrow bounded scope, if you're a startup wanting to get to market really quickly, just serverless monolith. It's not a bad idea. You can make it work. And then you can potentially migrate to a more microservices approach in time. I was dogmatic. I don't think I'm that dogmatic now. So your context and your goals, I think, matter a lot more. Automation is a must. My God, serverless systems are distributed systems. If you're using AWS, you're dealing with a bunch of other services apart from Lambda. You will end up with hundreds of interconnected moving parts. If you do not automate deployments, upgrades, monitoring, the complexity of the system will crush you. So you need to automate everything from the very start, believe me. As we've discussed, testing of cloud-native applications can be tough. Things are definitely getting a little bit easier, but explore SST and similar frameworks for testing and have a solid unit test strategy as well. Something we've discussed, going serverless may make architectural changes easier. Not easy, but easier. Yeah, I won't go on too much about it. And yeah, have a strategic mindset in mind. Go maybe serverless first, again, and if that doesn't work, fall back to other technical options that may potentially suit you better. I know I've gone a minute over time, but this is like, seriously, second last slide. I just want to look at the future for 1 second. Future of cloud computing. This is where we may be going. And I just want to say I am an advisor to this startup, so I've been talking to them a lot. So it's called Ampt, and it's interesting because they're trying to solve the complexity of cloud computing by building better abstractions. I think one thing that we've learned is that as humanity, we go towards a better abstraction all the time. So we started with punch cards, went to assembly, went to C, went to Java, went to 4th generation languages. Same with infrastructure. We started with on-prem servers, virtual VMs in cloud, containers, serverless, enabled by containers. And what these guys and similar companies, there are a few companies in the space, what they're trying to do is move us forward by becoming kind of like a compiler for the cloud. So the idea that they had is that you write business logic, they look at the business logics. Let's say it's an Express application, right? They look at the business logic and they infer the infrastructure that is required to run that business logic. And they deploy it for you as well. And at the end of the day, it doesn't really matter, whether your application runs on Lambda or containers. What do we care, right? Like most of the time, we're trying to solve a business problem for our customer. So why not let a cloud compiler kind of analyze what you're doing, deploy an effective version of your infrastructure? Because then it could get really smart. It could actually analyze your usage and dynamically replatform your infrastructure, say from serverless to Fargate, from containers, from Lambda to Fargate, if it decides that it's a more cost-effective option, or maybe go back. So all I'm saying is watch this space. This is very interesting. These cloud compilers or cloud operating systems, I think we'll start hearing about them over the next few years because they will try to kind of solve some of the complexity that we're still dealing with today. And I promise this is the very last slide. Go check out my project. Go check out the book. There's another great book called The Value Flywheel Effect. It's actually a book for business people and managers about serverless and why going serverless first makes you more operationally efficient. There's actually a case study in there about a cloud guru and how we kind of built our company from ground up. And with that, I think I'm out of time. Thank you very much.